Hello, this is a recording for cisp310 Tuesday, Thursday in 2018 fall. This is for the final exam, question number 3. Alright, so this question is all about understanding how the stack is organized. And this particular listing is an implementation of the Fibonacci program, which was the last homework assignment. So you can see that it's mostly done and mostly done correctly, except I didn't use the technique of naming the labels. So this way we are forced to have to understand what is on the stack, what is the stack pointer pointing to, and that sort of stuff. So the first thing we want to look at here is, so we just have to fill in all the blanks and describe what is in each register with each of those lines or each comment that has that notation. On the first one, CPR/CD, so C is basically a copy of the stack pointer. At the entry point of a subroutine, the stack pointer points to the return address. So C is going to be the address of the return address. So the address of, is actually important because C itself does not contain the return address. It has the address of the return address on the stack. After we increment C, it would point to the first and only parameter in this case. So it's going to be parameter n. Okay. Or if you prefer param1, would work too. Actually, I take it back because it is the address of the parameter. So it's the address of n, and then once we dereference the address of n, we actually get parameter n. Alright, so let's move on. So the rest doesn't really change anything. All they do is really it's conditional branches and stuff like that. So if you want to read through that, that's fine. Otherwise, they do not really change any value in the registers. So by the time we get to line 13, register A is n minus 1 because we have a decrement A. So this is n minus 1. And then decrement D to decrement the stack pointer because we are pushing n minus 1 on the stack. And then on line 16, we are pushing the return address on the stack. So by the time we get to line 18, A is actually the return address, and this time it's not the address of. So this is actually our return address back to fib. Okay, so it's not just any return address, it is the return address to get back to fib after the recursion. So then we perform the call or the jump to fib on line 19. By the time we get back, register A contains the return value, and I immediately use it to overwrite the location where the parameter was. So I'm reusing that location to store the return value of f of n minus 1. So that's kind of important. It will be coming in handy later on. And then when you get to line 21. So on line 21, we're making a copy of the stack pointer again. But remember, our stack pointer is now 1 lower than what it was. Okay, so that means it is now pointing to the saved value of the Fibonacci of n minus 1. After we increment, then it becomes the address of the return address again. And after we increment it one more time, it gets back to the address of parameter n. And then we retrieve n into A, and then we decrement it twice. So by the time we get to line 28, register A has n minus 2 in it. And then we push that on the stack using lines 27 and 28. and then we push the return address on the stack using lines 29 all the way to line 31. And then on line 32, we perform the call, or actually go back to the beginning of the subroutine to continue execution. On line 33, register A has the return value, okay? So it has now the return value of the Fibonacci of n minus 2, because register A contains the return value. On line 34, we are retrieving one thing from the stack, and the stack pointer is currently pointing to the saved return value of Fibonacci of n minus 1. So B gets the saved value of Fibonacci of n minus 1 here. It is not the parameter because we popped the parameter using line 33 already. So we perform the add operation on line 35. Then it becomes the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. Now here's the tricky part. We retrieve whatever D has into register B on line 34, and that turns out to be the saved value of the Fibonacci of n minus 1. On line 37, we didn't do anything to register D. There was no decrement, there was no increment. So register D is still pointing to what it was pointing to before. And as a result, it still has the same value. So on this line, we still have the Fibonacci of n minus 1. And that is the problem, because now we're going to use that as a return address to go back to the caller, and it's not going to work. But that's not for this class to figure out. The other class on Mondays, Wednesday, actually has to debug this program and figure out that it's not working correctly. Okay, so now that we have all the answers, the way it's going to be scored in this case is really looking at all of these things, and each one basically has its own entry in the rubric. Partial credit can be given, but it's going to be difficult to specify partial credit. Like on line 2, it is really the address of the return address, is not the return address itself. So that's important because there's a big difference between those two. One would definitely get the full score. The address of the return address would get full score. The other one, I'm not quite sure. Okay, I don't think it should be getting what is equivalent to a B. A C maybe. Okay, so this is going to be a little bit difficult for me to score, even though the correct answer is easy to check. Assigning partial credit is going to be a little bit challenging with this one. So anyway, you got the answer of this particular question, and I will post another video when it's time to do that. And let me stop.